Okay, so this is your first video lesson from me, and I'm going to tell you right now that I tend to mess up sometimes, so I'm going to do my best. So, Chapter 2, I've combined sections 1, 2, and 3 because it all deals with the same information, and that is talking about inductive reasoning. And we're going to do a lot of writing in this section, but you'll be fine. Anyways, so inductive reasoning is reasoning based on patterns you observe. So you're looking at something and you're deciding, well, if it's numbers, what's the pattern in the numbers? If it's a set of shapes, what's the pattern in the shapes? Okay, that's inductive reasoning. A conjecture is a conclusion you reach using inductive reasoning. So if I have the numbers 5, 10, 15, 20, I can make a conjecture saying that I'm counting by fives, looking at the pattern of the numbers. Not all conjectures turn out to be true, and you can prove that it is false by finding a counterexample. And that's an example that shows that a conjecture is false. Now, if you didn't realize on your notes that you have to write some of that stuff. Okay, you are watching this on your own, so pause it at any time. Use inductive reasoning to make a conjecture about the following. What is the pattern in the numbers below? Okay, so they give us the numbers 45, 40, 35, and 30. Okay, well, I can see that we're subtracting 5 each time. Okay, looking at the number pattern, and that's actually what I would say. I would say subtract 5. Okay, there's my conjecture. And that's all I would have to do. Okay, this one says give a counterexample for the conjecture below. Okay, if the name of a month starts with the letter J, then it is a summer month. So what they're saying is they want you to give an example that shows that is false. Okay, well, we know June and July are summer months. Okay, but there's another month that starts with J that's not a summer month. And I'm sure you all know what it is. January. Okay, so that's kind of what we're going to do, and then we're going to write conditional statements. A conditional statement is an if-then statement. So if it's cloudy out, then it'll rain. Okay, that's an example of a conditional statement. The hypothesis is the part P of the statement following if. So I say if it's going to rain, and then it's going to rain is the hypothesis. Then I will get wet. Okay, I will get wet would be the conclusion. It's the then part of the statement. They use P and Q. I don't know why. One of those things in math that we don't have an explanation for, but it is what it is. So again, write these down and pause at any time. You should be listening to this on your own. All right, so we're going to identify the hypothesis and the conclusion. We're going to underline the hypothesis and we're going to circle the conclusion. Now, a lot of times kids circle the word if with the hypothesis. Okay, that's actually not part of the hypothesis. Okay, so if an animal is a robin, then the animal is a bird. And you're going to wonder, okay, how did English come into math? Okay, and it's because when we do proofs, deductive reasoning and logic to do them. Okay, so the hypothesis is what follows the if. Okay, so in this case, an animal is a robin is the hypothesis. Again, do not underline the word if. Okay, the conclusion follows the word then, but it does not include it. So my conclusion would be the animal is a bird. Okay, simple as that, nothing else that you have to do there. Okay, next one, if an angle has a measure of 130 degrees, then the angle is obtuse. Okay, so again, an angle has a measure of 130 is our hypothesis. Okay, the angle is obtuse is our conclusion. It's really just as simple as that. Okay, if 3 plus x equals 5, then x equals 2. Okay, here's my hypothesis. Here's my conclusion. Okay, make sure that you don't circle then for the conclusion and you do not underline if for the hypothesis. Okay? Alrighty. Okay, we're going to write conditional statements. What does that mean for you? You have to write a statement using the words if and then, just like we saw on the last page. A lot of times when you're doing this, you have to add some words in order for the conditional statement to make sense. And make sure that you don't mix up and write the end part as the if part. And you'll see what I mean in a second when I do one. Okay. I'm going to write this as an if-then statement. So I always start if, well, maybe not. If angles are vertical angles, comma, then they share a vertex. Okay, that's the if-then statement. Now, do you see that I did not put vertex first? Here's what happens. Kids will say if angles share a vertex, then they're vertical angles. Okay, that's actually the inverse of the statement. So whatever it says first, it says vertical angles, that has to be in your if part. And then share a vertex has to be in the then part. Okay, don't mix those up. I'm going to try doing a smaller pen once here. Okay, whales are mammals. So here I'm going to have to add a couple things. I can't just say if whales, then mammals. Okay, that does not make any sense. I would say if an animal oh, that does not look like animal. If an animal is a whale, then it is a mammal. Okay? Sorry about the handwriting. I'm using a stylus and it's very hard. So notice in the if part, I have whale. In the then part, I have mammal. Okay, and like I said, sometimes you have to add words, but don't make things up. Okay? So the next one, I would say if the sum of two angles makes a linear pair, or make, okay, then the sum is 180 degrees. Okay, again, the last part of my sentence is 180 degrees, so I need to make sure that that follows the then part. Okay, so take your time on this. It's new and it's a lot of writing, and this is getting us ready to study proofs coming up. All right. The truth value of a conditional, that's a conditional statement, is either true or false. Okay? To show that it is true, you need to show that every time the hypothesis is true, the conclusion is true. So if I say if such and such, then such and such, they both have to be true. To show the conditional is false, you're going to find a counterexample. So if the hypothesis is true and the conclusion is false, then the whole statement is false. Okay? So these are conditional statements already written for us. Okay, and we're going to decide if it is true or false. If it's false, then we're going to find a counterexample. Okay, so the first one says if a woman is Hungarian, then she is European. Okay, that's a true statement. Whoops. Oh, I always do that. So I'm going to write true. And I don't need to do anything else because it's true. I don't need to find a counterexample. Okay? Next. Okay? If a number is divisible by 3, then it is odd. So, is every number that is divisible by 3 odd? No. Okay, I'm going to give you a minute. I'm going to write false. Darn it. Okay, I'm going to give a counterexample. I'm going to tell you or give you a number that's not odd that will divide by 3. I can think of a few. 12 is even. That's divisible by 3. 30 is even. That's divisible by 3. Okay, so on and so forth. I don't think I need to go on with that. Okay, so that's what you're going to do if they want you to prove it's false. If it is your birthday, then you will have cake. All right, well, that could be true. But is it going to be true for all instances? For every birthday, you will have cake. Okay, that's not true. What if I don't like cake? What if for my birthday, I will have ice cream? Instead of cake. Or brownies. Okay, so that's what you need to do, is to find something that would make that false. Okay, next one, if an animal is a whale, then it is a mammal. Okay, that is a true statement. A whale can't be anything other than a mammal, because that is the category that a whale is in. It is a mammal. And fun fact for you, they classify things by how we birth our young. So a whale is considered a mammal because it actually gives birth to its young instead of laying eggs or what have you. So just an interesting little biology tidbit for you. Okay, what is next? All right, so these are 3 things that we're going to be looking at. Okay, again, the conditional statement, use the given hypothesis and conclusion when you write it. Okay, that's where we wrote the if-then. And I don't know if you want to make a note. Okay, that's our if-then. The converse of a conditional. Okay, well, let's look at the example. If the measure of angle A is 15 degrees, then the angle A is acute. Okay, that's correct. We can say that conditional is correct. The converse is where you exchange the hypothesis and the conclusion. So we write it backwards. Example, if angle A is acute, then the measure of angle A is 15. That's the converse of the conditional. And then the inverse is to negate both the hypothesis and the conclusion of the conditional, which means we're going to say if this is not, then this is not. So if the measure of angle A is not equal to 15, then angle A is not acute. Okay? So we're going to be doing some of that and then finding out the truth values of it. All right, move it on. So in the previous table are the truth values of the related statements from the previous table. Equivalent statements have the same truth value. So I'm using the same statements that were in the table before, but now I'm going to say whether they're true or false. Okay? So if the measure of A is 15, then angle A is acute. Okay, well, we know right away that that is a true statement. Okay, we don't have to go into much more depth with that. Okay, the converse, if angle A is acute, then the measure of angle A is 15. Is that true or is that false? And if it's false, can we prove it's false? You write what you think it is. I'm going to give you a second. Okay, it's false. You might be like, well, why is it false? Okay, because an acute angle measures anywhere from 0 to 90. So the angle does not have to be 15 degrees to be acute. Could be 60, could be 89, could be 72.5. Okay, so then we look at the inverse. If measure of angle A is not 15 degrees, then angle A is not acute. Okay, that is also false because it does not have to be exactly 15 to be an acute angle. And you're going to find if the converse is false, then the inverse will be false. And I hope I said that right. All right, what is next? What is next? Okay, so we are given a conditional statement below. We're going to write the converse, and then we're going to write the inverse, and give the truth values for both statements. If a statement's false, then we're going to give a counterexample. Okay? So it says if a figure is a square, then the figure is a quadrilateral. Okay, so let's write the converse. So when we write the converse, we're going to make this, oh, whoops. All right, this is enough. Oh, this is just irritating sometimes. Okay, so when we write the converse, this becomes our if. Okay, this becomes our then. So we write if a figure is a quadrilateral, then the figure is a square. I need to use the smaller pen again. Okay. Yeah, that's better. Anyways, so if a figure is a quadrilateral, then the figure is a square. Okay, that's false. I hope everybody's following me here when I'm saying why it's false. Because a quadrilateral can be a rectangle, because a quadrilateral means a four-sided figure. Okay, it could be a kite, it could be a parallelogram. Okay, so that's false. So then if we write the inverse, which we put not into the original statement. So if a figure is not a square, then it is not a quadrilateral. Okay, so that's false too. Like I said before, rectangle. Okay, there's my counterexample. Boy, I write much better on the board. All right, let's look at the next one. Sorry about my handwriting, but like I said, I'm writing with a stylus, so it's hard. Okay, so we're gonna write the converse. So remember, this becomes our, oh boy, why do I do that all the time? Okay, seriously, I have issues. I don't know why this moved over. Oh, that's why. Okay, let's try this again. Okay, so this becomes our if. So if a number is, oh my gosh, my handwriting is terrible, is an integer, then it is a whole number. Okay, so that's the converse. Now, we need to decide if that's true or not. So give yourself a minute and think about that. Okay, integers can be positive or negative. Okay, but an integer is always a whole number. Okay, so this is true. So when we write the inverse, if a number is not a whole number, then it is not an integer. True. Okay, so remember, the converse is where we take the then part and write it as the if. And the inverse is where we insert not. Okay, the next one. If you are a quarterback, then you play football. So let's look at that now. So here becomes our if. If you play football, I'm going to put that down one more. If you play football, then, oh, that's much better. You are a quarterback. Okay, is that true or false? Okay, that is false. Why? Okay, because if you play football, you do not have to be a quarterback. You could be a running back, you could be a lineman, you could be a fullback, you could be a wide receiver, and then you're only good if you play for the Packers, of course. That's a different topic for another time. I'm so funny. All right, so we're going to write the inverse. If you are not a quarterback, then you do not play football. Okay, that's false again. So notice, if the converse is true, the inverse is true. If the converse is false, the inverse is false. They go hand in hand. So I'm going to put wide receiver. That would be my counterexample of what I could be if I play football, but I'm not a quarterback. Okay? Next slide. All right. I know this is a lot of information, so do your best. A biconditional statement is a single true statement that combines a true conditional and its true converse. And you write a biconditional statement by joining the two parts of each conditional with the phrase if and only if. Why do I do that every time? Okay, so this goes into a sentence. You no longer have the if and then. So the if and then are gone. I see students trying to write if this is this, if and only if this, then. Okay, it just doesn't make any sense. Okay. Oh, and another thing I forgot to tell you is that you can abbreviate, okay, abbreviate if and only if, IFF, that means if and only if. All right, so we're going to write the converse of the statement, and if it's true, we're going to write it as a biconditional. And I do not have a lot of room here. So the converse would say if two angles are supplementary, and I'm going to abbreviate because I don't have room, then the sum of the measures of the angles, and I don't think that's correct grammar, is 180 degrees. Now, that is true. Okay, so the conditional is true, the converse is true. So, since the converse is true, if the converse is true, use a biconditional statement. Okay, I am going to try to move this up a little bit, or I'm not going to have any room. And all that went away, but sorry. All right, my biconditional statement would be, we don't use if, that's gone. The sum of the measures of two angles is 180 degrees if and only if the two angles are supplementary wow. That was a lot of handwriting, huh? Never knew that when you were taking some English, huh? I don't even know what I'm saying anymore. It's late and I'm tired. Okay, so there's that one. Okay, we have another one. If a ray is an angle bisector, then it divides an angle into two congruent angles. So let's start by writing the converse to this. So if a ray divides an angle into two congruent angles, then the ray is an angle bisector. Oh boy. Okay. So notice that I inserted the word ray because if I say if it divides an angle into two congruent angles, then the ray is an angle bisector. Okay, well, I want to make sure that we know I'm talking about a ray in the beginning. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Okay, that is a true statement. How do I know that? Because I do. And you will get to know this stuff too. It just takes time. Okay, so my biconditional. So remember, this is the conditional statement. Biconditional. A ray is an angle bisector if and only if, I'm going to abbreviate it, it divides an angle into two congruent angles. Okay, so we know that's true because our converse was true. Now, notice that in my biconditional, I don't have if or then anymore. Okay, that's what a biconditional does. When you write a biconditional, I know that the conditional and the converse and the inverse are all going to be true statements. That's the only way that I can write a biconditional. Okay, but here's what students will do. They'll say, if array is an angle bisector, if and only if, then it divides an angle into two congruent angles. Okay, if you were to read that, it would make absolutely no sense. So, that is why. All right, next slide. Oh, we are going to write the conditional. So the if then, we're going to write its converse. And if they're both true, we're going to write a biconditional statement. Okay, so here is more writing for your hand to cramp because mine kind of is. So let's write the conditional statement. That's where we put the if and the then. So if a figure, I should have typed this, is a quadrilateral, then it has four sides. Okay? And that's true. A quadrilateral means that it's a four-sided figure. Okay, so this is our conditional statement. So let's write the converse. So we say if a figure has four sides, then it is a quadrilateral. Okay? The word quad means four. Okay, so that's true. And that was our converse. Okay? So now that we know our conditional and our converse are true, we can write a biconditional statement. So I'll say a figure is a quadrilateral if and only if it has four sides. Okay, that was weird. Okay, that is our biconditional. Okay, not too bad. Just make sure that you pay attention and you're not writing the conditional statement as the converse. Okay, so when I'm looking at this part, oops, has to be the if. This part has to be the then when I'm writing it. Okay? Because we're not trying to rewrite the sentence. We're just inserting if and then in there. Okay? Hopefully that makes sense to you guys. You know, again, type me a message on Canvas if you're confused about something when you get the worksheet tomorrow. Okay? Or if you need help with a skill builder question, ask me and I can guide you, okay? I'm at meetings, but I'll still have my stuff with me. All right, last slide. Woo, almost done. Yay. Okay, so let's look at this. Let's write the conditional. Boy, my handwriting is getting bad. So, if, okay, if 2 rays are opposite rays, okay, so here's my if, here's my then. Oh boy, I don't know what I just did. Oh boy. Okay, well, whatever. If 2 rays are opposite rays, then they share the same endpoint. Boy, is that sloppy. Okay, that's our conditional statement. That's true. All right, let's write the converse. So if 2 rays share the same endpoint, then they are opposite rays. Okay, that's true. So now I can write a biconditional statement. Okay, biconditional. So remember the word bi means 2, biconditional, so if my 2 statements are true, I can write 1. So I'll say 2 rays are opposite rays if and only if they share the same endpoint. Woo, we're done. Okay, probably took you this whole time to take notes, so if you didn't finish notes, you can finish them tomorrow, and then we'll have a worksheet on this, and your skill builders due Friday. Please behave for the sub. I probably should have said that in the beginning, but I didn't. So, oh well. Okay. That is it, my friends.